Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the free space management in operating systems. Free space management. Since the disk space is limited, we need to reuse the space from the deleted files for new files if possible. To keep track of the free disk space, the system maintains the free space list. The free space list records all the free disk blocks, those not allocated to some file or directory. Fourth one, to create a file, we search the free space list for the required amount of the space and allocate that space to the new file. Next one, this space is then removed from the free space list. When a file is deleted, its disk space is added to the free space. Next one, bit vector. The free space list is implemented as a bitmap or bit vector. Each block is represented by the 1 bit. If the block is free, the bit is 1. If the block is allocated, then the bit value is 0. For example, consider the disk where the block, we have the block numbers 2, 3, 4, 5, 8, 9, 10, 11. 12, 13, 17, 18, 25, 26 and 27 are free and the rest of the blocks are allocated. The free space bit map would be here they have given the values. Next one, the main advantages of this approaches is it's relatively simultaneously and efficiency in finding the first free block and n consecutive blocks of the disk. Next one is linked list. Another approaches to the free space management is to the link together all the free disk blocks, keeping a pointer to the first free block in the special location on the disk and catching it in memory. This first block contains a pointer to the next free disk block and so on. In our example, we would keep a pointer to the block 2 as the first free block. Block 2 would contain the pointer to the block 3, which would point to block 4, which would point to the block 5, which would point to block 8 and so on. However, this scheme is not efficient to traverse the list. We must read each block, which requires the substantial input-output time. Third one is grouping. A modification of the free list approaches is to store the addresses of the n free blocks in the first free block. The first n minus 1 of these blocks are actually free. The last block contains the addresses of another n free blocks and so on. The importance of this implementation is that the addresses of the large number of free blocks can be found quickly. Next one is counting. That is fourth one. We can keep the address of the first free block and the number n of the free contiguous blocks that follows the first block. Second point, each entry in the free space list then consists of the disk address and a count. Next one, although each entry requires the more space, then would the simple disk address. The overall list will be shorter as long as the count is generally greater than the 1. Next one, recovery. In recovery, we have the 2 points. First one is consistency checking. Second one is backup and restore recovery. Files and directories are kept both in main memory and on disk, and care must be taken to ensure that the system failure does not result in loss of data or in the data inconsistency. Consistency checking. The directory information in main memory is generally more up to date than in the corresponding information on the disk because cached directory information is not necessarily written to disk as soon as the update take place. Second one, backup and restore. Magnetic disks sometimes fail and care must be taken to ensure that the data lost in such a failure are not lost forever. Thank you.